Hello everyone, welcome to today's session on sampling distributions from probability and statistics. So I am Mr. P. M. Chellapandi from Department of Mathematics in SNS College of Technology, Coimbatore. In this session, we are going to understand the meaning of sampling distributions, why they are important in statistics, and how they help in hypothesis testing and decision making. By the end of this session, you will clearly understand the concepts like population, sample, parameter, statistics, and standard error. Let us begin. So, here, first, let us recall some basic concepts so that we can understand this concept clearly. So, before learning sampling distributions, we should know some basic concepts. So, in statistics, a population means the complete collection of data or observations. A sample means it is a smaller portion that is selected from the population. For example, if we want to study average height of all engineering students in Tamil Nadu, it is difficult to collect the data from every student, right? So instead, we select a smaller group called a sample, right? So a parameter describes a population characteristics, while statistics describes sample characteristics. So these concepts from foundation for understanding sampling distributions, right? Now, why do we need sampling distribution? Now, the important question is, why do we need sampling distributions, right? Suppose we take different samples from the same population. Each sample may produce a different sample mean, right? So this variation naturally occurs because samples are randomly selected, right? So sampling distribution helps us to understand how these sample means behaves, right? So it tells us how close the sample mean is to the population mean, how much variation exists between samples, how reliable our statistical estimates are without sampling distributions, statistical inference and the hypothesis testing would not be possible. So sampling distributions helps us make predictions and decisions about large populations using small samples, right? Now, let us define sampling distributions, right? So here a sampling distributions is the probability distribution of a sample statistics obtained from all possible samples of the same size, right? The most common example is the sampling distributions of the sample mean, right? So the important properties are the mean of this sampling distributions is equal to the population mean. The standard deviation of the sampling distributions is called the standard error. The formula for standard error is the standard error is equal to sigma is divided by square root of n. Here sigma represents population standard deviation and n represents the sample size. As the sample size increases, the standard error decreases. So that means large samples produce more reliable results, right? Here, now let us discuss one of the most important concepts in statistics, that is the central limit theorem. According to the central limit theorem, as the sample size increases, the sampling distributions of the sample mean approaches a normal distributions. So regardless of the population distributions, this theorem is extremely important because many statistical methods assume normality, right? So in practical applications, if the sample size is large, usually greater than 30, the sampling distributions becomes approximately normal. So this allows statisticians and engineers to perform hypothesis testing and confidence interval estimation effectively, right? So here now let us try some assessment questions. First question is, which numerical value describes a characteristics of population, right? The correct answer is parameter. The second question is, what is the standard deviation of the sampling distributions called? So the answer is standard error, right? So it is standard error. Now the third question is, according to the central limit theorem, what happens? The sample size increases. The correct answer is the sampling distributions approaches a normal distributions, right? So the fourth question is, if the population standard deviation is 10 and the sample size is 25, calculate the standard error. So by using the standard error formula, we can get the answer. So the answer is option B, right? Now let us summarize the key concepts learned so far. So here, population refers to the entire data set. Sample refers to the subset selected from the population. Sampling distributions explains the behavior of sample statistics. Standard error measures variability between sample means, and the central limit theorems ensures normal distributions for large samples. So these ideas are essential in probability, statistics, machine learning, and data science, right? So here I have shared the mind map, which is explaining whatever we have discussed in the starting to till now, that I have given as a mind map for quick review. So I have shared some reference link also, you can get it and to gain the more knowledge about this topic. So thank you for watching this video. I hope the session helped you to understand the sampling distributions clearly. Thank you.